Welcome back to the Aerospace Executive Podcast. Happy almost end of 2022, but I am thrilled to have Craig Boswell with me. Craig runs a fascinating business. He's the president of HOBI International out of Dallas, Texas. HOBI is a recycler of consumer electronics, computers, precious metals. And I thought it'd be great to have him on with all the focus on EV and batteries and green energy. I just thought it'd be a great topic to talk about. So thanks, Craig, for coming on.
Thanks for having me. I appreciate it.
So Happy New Year. Christmas was good for you guys?
Yeah, very good. Very good. Happy New Year.
So hope 2023 is as good as 2022 was for you.
Yeah. Thank you.
So let's talk about it. We were just talking about it a little bit. We've obviously talked about, you're electronics recycling, and most of your clients are large corporate accounts that are looking to dispose of IT in kind of a contract fashion. Talk more about it in broad and general, and then let's shift gears a little bit.
Yeah, certainly.
About what you do.
So if you look at the landscape of the electronic space and the IT space, companies have recognized that at the end of life, the burden for disposition of the equipment they use really has a lot of facets to it. First of all, they got a data security risk. You don't have to read the Wall Street Journal too often, and you'll see an article about someone that didn't manage their data very well, and that doesn't look very good in the press. They also do have an environmental risk. The electronics that we use on a day-to-day basis seem very benign from an environmental standpoint, but they do use heavy metals that can be considered hazardous if they're not disposed correctly. The batteries, like we talked about prior to starting the show, lithium-ion batteries are considered a hazardous waste if not disposed of properly. And that falls on the company that owns those materials. And then even beyond that, there's value there. The used electronics market is a multi-billion-dollar market worldwide. So, if you're a company and you've used your Surface Pro tablet for a couple years and we're going to upgrade because we got to have the latest and greatest, that Surface Pro tablet is still very valuable. It's valuable, from an environmental standpoint to extend the life, but it's also a great way to bridge the digital divide. Companies like mine, we sell electronics all over the world. And there's plenty of places in the world, for instance, that a cell phone is the only way to communicate. There is no wires in the ground. And so the easiest way to create communications and computing power for your populace is to throw up towers. So our clients, which tend to be Fortune 1000 companies, basically are looking for a turnkey solution that when they have assets to dispose of, we come in and we bear that data security risk, we bear that environmental risk, make sure it's either reused properly or recycled for recovering the gold, silver, copper, and other metals and plastics. And we provide them with a sustainability story around how they're protecting the environment at the end of the life of these items.
So how much, we were talking about it last week. So we were talking about my iPhone 12, which I'm probably going to have to upgrade because the battery keeps running down on it. How much of that iPhone 12 is recyclable? What's in it? How much is recyclable? And then I want to shift the gears and go, okay, now the future is Tesla and EV, or maybe the future is Tesla and EV. And I want to talk about the challenges of that too.
So first of all, call me when you're ready to upgrade. All right?
I will do that.
Don't forget about me.
Yeah.
But yeah. If you look at a cell phone is really a very recyclable item. First of all, if it's an iPhone 12 and you send it to me with a battery that wouldn't hold a charge, we wouldn't necessarily recycle that. We would clear the data. We would replace the battery, put a brand new battery in there, and we would sell it either domestically or internationally. There's hundreds of online platforms that we can sell that. We sell a lot of our phones into the EU from the US and other markets where it's a non-subsidized market like the US market is subsidized by the carriers. But if we did have to recycle it, let's say it was an older device, you're looking at, first of all, almost the entirety of that phone. In fact, the entirety of that phone is recyclable. The things that we would recover would be aluminum around the casing and the frame, precious metals. It's interesting. There's a term that's evolved over the last 10 years called urban mining. And what they're talking about is some of the most hazardous things in producing electronics happen when we dig the materials we need for those electronics out of the ground. Gold, silver, palladium, platinum, cobalt for the batteries. Mining is very intrusive to the environment. And you have this cell phone here in your hand, and that cell phone is actually 10 times more rich in gold than the ore I would dig way down in the ground to dig out. And then I got to refine the gold out. And when I dig up gold ore, I sometimes pull up mercury to the surface, which isn't great. And so, we can recover all those materials, and they're right here in your hand, and you hand them to me, and the velocity by which we can get that raw material item, that potential raw materials from in the phone back into, it might be gold that goes back into electronics, might be gold that you wear on your ring when you get a new piece of jewelry, or aluminum that could go into cans instead of phones. All those materials, they're right here in your hand, and with a tremendous velocity, we can get those raw materials back into the manufacturing stream. And, I think it's a popular term to talk about the circular economy. Everybody wants to focus on, that is the future, a circular economy where we're not creating waste. But if we don't close that loop, if you get done with that phone and you stick it in the drawer, it's not a circle, right?
Right.
It's more a letter C at that point. What closes the circular economy is getting those items back into this recycling infrastructure, whether it be your phone or your PCs or any other type item, an EV vehicle, those types of things, getting back into the recycling structure where we can get those raw materials back to the manufacturers.
So how much? Yeah. So if you're talking about the manufacturers, your printed circuit board makers, even Apple, Samsung, IBM, whoever's making, Dell, whoever's making computers, are they active buyers of the recycled material themselves? Are they buying the raw material and then putting it back into their?
Yeah, in some cases directly, in some cases secondarily. So if you look at the infrastructure for aluminum, for instance, a tremendous amount of manufactured aluminum contains a large amount of secondary aluminum that's been recovered. So they don't necessarily care if it comes from an iPhone or a beer can, right? They just know that they're buying aluminum that has a large amount of secondary material that's been injected. Same way with gold. Where it gets more direct is with plastics. So plastics are a tough item to recycle. Milk jugs, not so much, right? They're uniform material, fairly consistent. But if you look at the plastic that would be contained in an electronics device, first of all, it might have lots of different colors. And, we're pretty particular about our colors. Sometimes I want the pink one, I want the blue one. And it's hard to take, green plastic and make a pink iPhone.
Right.
And so that's where we tend to close the loop a little more directly with the manufacturers, trying to get the plastics that's unique to their products, both from a composition and a color standpoint, back into their manufacturing stream. Whereas the more commoditized items like copper, gold, aluminum, those tend to go back to just a general commodity and then be injected back into the the manufacturing infrastructure.
I got you. No, it's fascinating. So let's talk about, now we talk about, we're talking about, so obviously consumer electronics around here, the big thing around here in North Carolina is stealing catalytic converters off of church buses for the platinum content. So obviously there's some value. There's a lot of value there. But let's talk about, so in aviation, aerospace, everybody's talking about, the electric jet batteries. Everybody's talking about, the new Ford Lightning batteries, Teslas. I mean, there's a lot going on there when you talk about the need for, 21st century electronics, lithium batteries, rare earth. Is it real? I mean, how far ahead of ourselves are we getting here when we say, hey, by 2030, we want every car in the United States sold to be electric?
So from a recycling standpoint, we're making a tremendous investment in recycling infrastructure for the batteries. If you follow the industry at all, companies like Redwood and Li-Cycle and Retrieve had raised well over $1 billion to get prepared for recycling the batteries. The problem is the batteries aren't coming out very fast, right? So we are needing new raw materials for these vehicles. And the best batteries right now from a power density standpoint, and so that's the amount of power that the battery can have per unit weight. Weight's important. The more the battery weighs, the shorter your range, and then you need more power in a bigger battery. Those are nickel metal cobalt batteries. The cobalt is a tough item. A lot of the cobalt comes from the Congo, and that's a tough place to be mining. There's a lot of issues with that. So there is some, infrastructure problems right now with saying, could we ramp up to 5 or 6 or 7 order of magnitudes more battery production than we have right now? There's a lot of research being done to try to avoid that. There are some cheaper alternatives that don't involve cobalt. The most popular right now is lithium iron phosphate battery. It's not quite as power dense, but it's considerably cheaper. It works great. So we're sitting in the U.S. We always joke about that, a weekend drive in the U.S. might be from Dallas to Lubbock.
Right.
A weekend
6 hours.
drive. Yeah. A weekend drive in the EU might be from the Eiffel Tower to the other side of town, right? So a lithium ion phosphate battery in that type of application isn't too big of an issue. It doesn't have the range, but I don't need the range. I can, I do a few hundred miles in a week. My commute's 180 miles a day. And, I want that better battery, but, we do have an issue with materials. The industry is aware of that. Like I said, from a recovering material standpoint, we're generating a lot of capacity, but that's really not going to be needed for 5 or 10 years. If you look at the aerospace application, obviously even more demanding application, right? Don't want to be up in the air or run out of juice. That's probably not the ideal case. So, you're going to be using the highest end batteries possible because, you got to overcome the weight of the battery, so you want the best power density possible. So right now you would be talking the nickel metal cobalt batteries. There's research being done in solid state batteries that'll improve that power density even more. It's the battery technology is one of the big limiters here, and on what we can do and what applications will work. And then we also have to look at the safety implications of using lithium batteries in those types of more critical applications like flight. If you do have a battery episode due to damage in a vehicle, you pull off, you get out of your car, and it's terrible if the car burns, but I just got to pull off the road and get away from the car. Obviously, that happens in an airborne situation, a much different scenario.
Right.
And so, we're addressing those as fast as we can. Everybody, the Holy Grail is a very safe battery with tremendous power density that's cheap. Yep. And it's still the Holy Grail. It's out there buried somewhere. We can't find it.
We're not there, but you're even saying even lithium right now to recycle a lithium battery is not an easy process. They're combustible. They're easily combustible.
From a supply chain standpoint, we're developing a lot of capacity for recycling the batteries, But, it's kind of, we go back to your cell phone. If I don't get the cell phone, I can't recycle it.
Mm-hmm.
Well, these vehicle batteries, whether they be for flight applications or for vehicles, they're a lot bigger, they're a lot heavier, and they tend to be more spread out. They don't tend to be consolidated necessarily in one location. So from a standpoint of getting them to the recycling, we have a couple issues. One is we do have the issue that from the Department of Transportation perspective, when you're transporting these batteries, you're transporting a hazard because it could cause a fire.
Mm-hmm.
You have to be careful about how it's handled and packaged. The other thing, a lot of these batteries for vehicles are fairly high voltage, and some of the vehicles a deadly high voltage. So now, you tell me that I just pulled a battery out of a BMW in downtown Dallas, come pick it up and, take it to recycling. Well, I got to make sure I handle it correctly, that I don't kill somebody. They touch it and it's still fully charged.
Mm-hmm.
I got to make sure it's packaged correctly. It's transported on the type of vehicle where it can be done safely, where it doesn't represent a fire risk. And then when it gets to the facility, I have to disassemble that battery with safety in mind, both electrical hazard and fire hazard. God forbid the battery was damaged. Now it becomes even more of a fire risk. And, these are intense fire. One of the problems with the lithium, of course, you think, 4th of July sparkler magnesium, right?
Mm-hmm.
Same area of the periodic table. It burns hot and it burns fast. So, everything around it catches on fire. It's not just that battery causes a fire. Yeah. But it's burning so hot and so fast that there any combustible material nearby, you're catching in on fire. So,
it's burning the truck. It's burning the truck that it's transported on. It's burning the road that's underneath. That's on. It's
exactly. Lots of videos of burnt up UPS and FedEx trucks on the web.
Now you see it though, but like the auto insurance industry. I'm trying to think of the name of the business. Car gets wrecked. And then it goes obviously to a salvage yard,
Mm-hmm.
And then, there's a huge business around, insurance, cars and things like that. I'm assuming there are now businesses that are popping up, or maybe even the auto recyclers are starting to figure out, hey, maybe it's time we start investing in training and processes and people surrounding, the EV market.
Yeah, the most logical infrastructure to do this is the auto salvage infrastructure, right? It's a very well established structure. I know a lot of people in that space, much more technical than you would envision.
Mm-hmm.
You think of it as a junkyard, parts recovery and parts harvesting and the remanufacturing of parts. If I went to get a new alternator for my truck today, I would buy a remanufactured alternator because that is a very controlled process. The recovery from the salvage vehicle is done controlled, and the testing and remanufacturing is done real well. And the same could be done with the EV batteries. And the best case possible with the batteries, obviously, is also reuse. When we look at the 3 R's of the recycling space, it's reduce, try to use less materials to have impact. Then it's reuse, then it's recycle. Reuse is, if you look at carbon footprint type measurements, 10 times more effective than recycling, because when you recycle, you got to go back through all those melting and heating processes. When you reuse, you save everything from mining new ore out of the ground to the semiconductor manufacturing and everything else. So, we're looking at reuse options, and the salvage industry, the auto salvage industry, is looking at those things. What does the market look like? One of the problems we're having is unlike a lot of things in a vehicle where it's been fairly standardized across makes and models. Every new vehicle that comes out is a completely reconfigured and new battery.
Mm-hmm.
And so, I could figure out, great, I know how to reuse the battery out of, a Tesla Model 300 or something.
Mm-hmm.
But that's completely different than the Nissan Elf.
Right.
And so now I want to use the battery out of that for a reuse application. and I have to have a completely different engineering analysis of that battery and how it could be reused. One of the most important aspects of that is safety. What mitigates the opportunity for battery fires to a large extent in the application phase is what's called the battery management system. And it does things like detect potential thermal runaway and control the amount of current that can go to the battery so it doesn't heat up, start a cell on fire, which, like we said, propagates to everything. And the next thing you know, the whole car is burning down. And those are unique to each application. And if I can't, I may be able to disassemble the battery into individual cells and say, hey, this could be used for backup power for a home. But if I can't put a good battery management system around that, that application can't be exercised. So, as we look at emerging spaces like the aviation space, it would be the cost avoidance that could be accomplished and the environmental benefit that could be accomplished by taking batteries out of that application, which will be a pretty demanding application. Your vehicle gets to 85% range and you say, okay, it might be close when I'm driving home, but if I'm running out, I can pull into a charging station. If you're up in an aircraft and you run out of battery power, not a lot of charging stations in the sky, right? So we're probably going to be taking batteries out of service at a much more regular basis in that application from a safety standpoint. Maybe the threshold will be 85, 90% capacity, 80% capacity, whereas in the vehicle space, people go well below that. Now we have these really good batteries that would be great for reuse, but if we don't look from the front, design, if you look at the ability to recycle electronics, I was an electronics design engineer in my previous life. I sealed the fate of the recyclability of those processes when I finished my CAD drawings. If I thought about end of life, I could do some things to make that product much more recyclable. If I ignored end of life, I could make lots of critical errors that made end of life reuse and recycling very, very difficult. Same is true in the battery space. If I think about end of life, maybe I look at modularity. I look at a battery management system that could be redeployed in a fixed power application. And now those batteries are actually valuable at end of life rather than being a cost to dispose of, because the only opportunity I have to get rid of it is to put it on a truck it, 90 miles as hazardous waste, and then only recover the cobalt once it finally gets to a smelting facility, 300-400 miles away.
Yeah, it's amazing to me because now you're talking about is, and I'm sure people are out there thinking about all this, but it's new standards. Okay. So we're talking about, everybody talks about, oh, it's really easy. Just make it an EV. It's a battery, right? Now you're talking about, well, hey, maybe we need a standard that everybody lives to for a decade versus which limits now innovation. Because, you think about like every iPhone, comes out with every time an iPhone comes out, it comes out with 30% more battery life. Well, if you do that with a car, the battery that was in the car now has to get replaced. Well, you can't put it in, you can't put it's a totally new design. And now you're running that. Now you're talking about electric airplanes, now you're limited, you're limited to the technology. You can do that. So it's like ultimately development of standards, which people really aren't, I'm sure the experts are thinking about it, but the layman really isn't. And I think this podcast is designed more for the layman, just to talk about the challenges of, hey, it's not as easy as everybody thinks.
Yeah. And it's a balancing act, right? In anything, there's been hundreds and hundreds of studies about how sensitive are we to green. And, we're pushing EVs because we see it as more green, but there's other benefits to EVs beyond green, noise and other things. And we say, well, how can I make it greener? Well, I can make it more recyclable. But if I look at those trade-offs, it may be a much, much better product. We talked about nickel, metal, cobalt versus lithium, ferrous batteries. the nickel metal cobalt batteries, I've eliminated cobalt, but I've also eliminated range. Well, that doesn't really make sense, especially in the aeronautics aviation space. Range is going to be, power density is going to be I got to lift it off the ground, right? I'm all about weight and power density. I'm going to use the best battery I can possibly use, and I'm going to trade that off against environmental issues and, end of life issues, and do the best I can where I can have an impact, where those trade-offs is maybe a win-win, or at least win and not a loss. I should be looking at those, and standards around that are one ways to do that. In the commercial electronic space, in the CE space, if you look at consumer electronics, there's a standard called EP. And what EP does is it looks at the products and it says, all things being equal, did they make good trade-offs from an environmental perspective and a safety perspective on this? And if it passes a certain threshold, it gets, a gold rating, a silver rating, or so forth. And then purchasing decisions, for instance, within the government, are made around seeking those products where those trade-offs were made. And in some cases, those are significant investments in research by the manufacturers to say, what is the best approach here? Let's open our eyes to new approaches that have both utility for the user of the product and have mitigated some of the environmental impact.
That's great. Now we were talking, kind of going back to something different. Let's talk a little bit of recycling. Obviously, the aircraft carrier that I was on, we talked about, they towed it to Brownsville, Texas, and cut it up. Tons and tons of ferrous and non-ferrous metal, not to mention copper, precious metals, whatever else is on board. I don't know what they put in aircraft carriers. I'm sure it's much more than steel. And obviously if they're spending that much money to tow it from Bremerton, Washington to Brownsville, and then taking 2 years to cut it up, there's a return there.
Yeah, I think it's funny because, the average consumer, when they think of recycling, you often think of the bin in your garage, right?
Right.
And I throw my milk jugs and I throw my aluminum cans. The industry infrastructure is so much greater in that. On the commercial level, you can't drive by any real commercial facility and you won't see a bin in the back of that facility that's for metals, aluminum or copper or ferrous metals. You look at electronics, a multi-billion-dollar industry around recycling electronics. Now, the fascinating thing, it's not much different than the can in your garage. You throw a milk jug in there and an aluminum can in there, and it goes to a facility, and their job is now to separate the milk jug from the aluminum can. When it's an aircraft carrier, it's a little bigger problem, a little bigger product to deal with, but their job is to separate the steel from the aluminum, from the copper, from the glass. It's the same basic thought process, just with torches and grinders and hundreds of people.
Or a 747 for that matter.
Or a 747.
When you think about the 747s, cutting them up, they're stripped down for parts, and then 10,000, 20,000 pounds of aluminum and, whatever else have you, right?
You look at just jet engine blades. Jet engine blades, titanium and tungsten, have to high speed, very strong, have to deal with very high temperatures on the edge of the blades. That involves a mixture of two materials. And there's companies out there, their job is to separate those two materials and get them into the recycling infrastructure. And again, if we look at the circular economy, which I think is a great concept, if we put it out there, how do we get it back into raw materials? That needs to be applied beyond just our, packaging on our groceries and the cans we drink out of. You look at everything in your office, from the concrete that your home was built on. Concrete can be recycled, and there's a process for recycling concrete. And if it's done correctly, if it's corrected correctly, you can inject it into some fairly good applications. Vehicles, it's the same way. Jet engines, all these things. And there's two aspects. One is the urban mining aspect of it. It's a lot better than mining it out of the ground. And then the second is some of these resources aren't unlimited. If we keep burying them in the landfill, someday we're going to be mining back into the landfill to get these things we buried, because that's the only place they still exist.
Yeah. I suspect more and more laws are going to come into play to promote the circular economy. Electronics must be recycled. Your concrete must be recycled. Your metals must be, things of the sort. I suspect that's just going to come more and more into, state and local laws, at least in the United States. I know in Europe they're fanatical about it. Back when I lived in Germany, they're fanatical about, brown glass goes in this can, green glass goes in this can, aluminum goes in that can. But it was cool to see it. That was 30 years ago, quite frankly.
Yeah, and it's still the same today. We're one of the few countries that still have mixed bin recycling. We talked earlier, my son's in the Navy, stationed in Japan, and I got there with a bottled water. And, in the city he was in, you had about 9 different categories you had to separate your recycling in. And I pulled my bottled water out, and the logo was printed on it. And he goes, "This is completely unacceptable. The water's here. The label is separate from the bottle because it's 2 different type of plastics. So everybody in their home is going to cut that label off. The label goes in one stream and the bottle goes in another." And my son goes, "I don't know what to do with this bottle. It's contaminated with this printing. I can't do anything with it." But those are the types of decisions that, is going to, and, we are seeing some laws get passed. 26 states in the U.S. have electronics recycling laws. Most of those laws put the burden on the manufacturers. So if you look at, a lot of the states, Illinois, Texas, if I sell, phones or computers in the state of Illinois and I sell 1,000 pounds, I got to collect 1,000 pounds of waste electronics in that state. And the manufacturer has to pay for that. And many companies in my industry, that's the end of their end. They're collecting electronics from consumers to help the manufacturers meet their obligation for recycling. We may see the same thing in the electronic vehicle space. If Ford sells you an electronic vehicle, they may be mandated by law to take that back at end of life, because of making sure that battery gets recycled properly. Or some places have gone to the point where they actually lease you the battery. So you own the car, but you're leasing the battery. And that way, when you go to replace your battery, you don't own it in the first place. And it goes back to the manufacturer, and they can use that as part of their infrastructure, either retest and reuse or recycle and get the raw materials.
Interesting. I mean, you can see a whole lot of different, I never thought about that, a whole lot of different applications for, one new business is battery leasing. Two, it eliminates the worry that people have if they buy an EV, what happens, how much does it cost me when the battery goes out? And 3, what do I do with it when it's all over? But, it's the whole thing. I mean, it's just, it's fun to watch the whole sort of transition to sustainability and green. But, to think about what all is required, to make it all happen. There's a lot of different thought, a lot of where there's a challenge, there's a lot of opportunities out there as well, is what you're saying.
Yeah. And we've come a long way. I mean, I look at when I grew up, and, it's hard to believe that I grew up in the 60s, I'm sure, but I look back in the 60s, and when I was a little kid in the car, it wasn't uncommon to see people throw trash out the window of their vehicle, right?
Oh, yeah, sure.
And today you see that and you're horrified.
Yeah.
And yet, when I grew up, there wasn't much, even in, when I first owned a home, there wasn't residential recycling in my neighborhood. We didn't think of everything went into the trash can. That's just what we did. Now, almost anywhere you live in this country, there's, recycling option in the residence. And we have a generation coming up that the term circular economy is really meaningful for them. And, they think about things like, how is the circle being closed? And what are the impacts if we all switch to electronic vehicles? Is that necessarily good? They think beyond just the greenwashing of, well, I still got to charge that vehicle. And if I'm using coal electricity to charge that vehicle, is it a net environmental gain? Yeah, it's a net environmental gain if it's green electricity, but what are the total impacts? And the fact that I got to mine cobalt and all that, we've come a long way.
Yeah, well, that's the whole, I think that's the whole thing about is, there's no such thing as zero. When you think about our goal is zero, that's a goal that really, in my mind, promotes abuse. Zero tolerance, zero carbon, zero emissions. It's like, well, we don't really need zero because the earth can handle so much. But reducing it to the least amount possible. Everybody wants clean air and clean water. So let's reduce it as much as possible without losing the economics there or the laws of diminishing returns, right? Yeah, it's ultimately there's a balance, and let's find the right balance. But it's fascinating to me how it's all coming around, and both the challenges and opportunities that are there in front of it.
Yeah, definitely, and it's going to be trade-offs as we evolve society-wise. We may accept more painful trade-offs than we have historically. Our consumption habits may change around more environmentally beneficial. Maybe, the bag I buy my chips in isn't as sturdy as it once was because it's made from recovered and recyclable material. And, I can't run a truck over it and still have chips I want to eat. The bag busts open in that case. But, that's the key, is that we are open to trade-offs, but we also understand that it's a road and it's a process. There's certain things that, it's almost a waste of effort to look at the U.S. right now and say that we should just turn everybody over to electric vehicles. There's many applications right now where electric vehicles, for instance, my case, if I had a much longer commute than I had, it might be very, very difficult for me to use an electric vehicle.
Right.
And so it's not something that I would buy or seek out. So
you think about, that's when the options come up. Well, okay, well, what about a hybrid? Hybrid that gets 60 or 70 miles, effectively 60 or 70 miles to the gallon. Well, that's pretty good, right? It's not, it's not zero, but it's good. So it's cool. Hey, Craig, how do people get a hold of you?
They can certainly shoot me an email. I am at cboswell, CBOSWELL @hobi.com. And our website is www.hobi.com. You can find a lot more information on these types of things there. We got a lot of blog posts and articles there about these issues and what the industry is doing about it. And if you have questions, just reach out to me. It's a great thing to have your profession be in an industry like this, because there's so many interesting subjects and so many interesting things going on, and it's moving so quickly, and something I love to discuss and, think about where the future is going to go here.
It's awesome. I was looking forward to this podcast because I think just what you do to me is fascinating. So thank you for coming on. Let's do it again.
All right. Super. Thank you.
Thanks, Craig. I hope you enjoyed the latest edition of the Aerospace Executive Podcast. You can reach out to me directly, Craig at northstaresg.com, or check us out at www.northstaresg.com. You can subscribe to this podcast on iTunes, Stitcher, Podbean, or on YouTube. Just do a search for Aerospace Executive Podcast. Thanks again. I'm Craig Piven.